Our Intelligent Arctic Environment, a future vision from 2025 to 2040. Now, when I arrived for the first time in Apatiti more than 30 years ago, I worked with Dr. Sasha Baklanov and Professor Gennady Kalabin on the KolaNet project, which was a quick response network for potential environmental or radiation catastrophes within the Kola-Peninsula. Then when I was starting this presentation, I thought, well, 32 years later, what would I suggest focusing scientific resources in? Well, I believe I would recommend scientific projects that focus on the applications of artificial intelligence and machine learning to our intelligent Arctic environment. Now, it's been a long journey for me during these last 30, 40, 50 years, from Cambridge to KolaNet and beyond. 9 sections to the presentation. My great-great-grandfather worked in the historic city of Huzovska, which is now Donetsk. He worked as the chief mining geologist with an enterprise that was known as the New Russia Company. I'm very proud of his heritage. He worked in Donetsk, setting up and managing the major coal mines within the region. Another photo of him on one of the troikas in the surrounding countryside. Now, from that industrial era of the 19th century, we're moving forward to the 21st century of computers, internet, and artificial intelligence. By the way, cyber means to steer a ship, pilot a ship. Cybernetes from the Greek. So from Cambridge to KolaNet. This year is actually the 55th anniversary of the internet, a topic that I worked extensively on during the 1990s and beyond. The era of network intelligence, the 20th century. My first scientific paper was published in 1970 on the applications of digital communications technology to our telephone networks. Then I moved on to Cambridge University to the Department of Mathematics, where I studied for a PhD in machine learning and artificial intelligence. You'll find my thesis online, The Evolution of Stochastic Automata. These were early days for artificial intelligence, and as you can imagine. Now, if I move forward, I came to Apatiti, to the KolaNet project in '92, and we opened the KolaNet office downstairs in INEP in April '93. Here you see Vladimir Kalinikov, Gennady, Sasha Baklanov, and others all involved in the project. And myself in the office with a digital computer, signing the final agreements with Baklanov, Gennady, and myself. We did many innovations during the 90s. We started up the first live web camera within the Kola Arctic, summer and winter, with a temperature readout. Winter view from the INEP computer laboratory. I visited the Kola nuclear power station several times to discuss the project. And we had a fantastic team, international team from Norway, Sweden, Finland, Germany, and many institutions from Russia, including St. Petersburg and Moscow, and of course the Kola-Peninsula. This year is also the 25th anniversary of our first publication that we jointly managed, the INEP brochure, with Gennady again signing it off. Got a copy of the first publication here. And part of the team, Sasha Baklanov, Sergei Morozov, and of course Alexander Perlikov, who unfortunately has died since the last INEP conference here 5 years ago. Here's Alexander Perlikov in the office. He was a computing pioneer. He organized the first video conference from INEP to project partners, including ourselves in the UK. Here I am sitting in the same chair, in the same office here at home with my beloved wife, Valentina, talking to Gennady and Tatiana over the internet. Very early days, 1998. In fact, it was so early, it was published in one of the major British newspapers, Daily Telegraph, on the 20th of March. Now it's normal that we communicate with video all around the world. Many photographs in the archives online. There's a link up there if you're interested in viewing them. Another great loss since the last conference, Dr. Anatoly Lukin, a brilliant fish scientist, water scientist, with his barbecue on Imandra by the rest base. Another anniversary I'm very proud of. 30 years ago, we organized the first internet video conference between Moscow, ICI, the Institute of Cosmic Research, and Washington in America, NASA. You'll see myself on the right-hand side there with rather browner hair and 30 years younger. Some colleagues, the team from the Russian government, waiting their turn to speak to Tony Villaseñor, the director of NASA networking over in Washington. Now, this is a historical theme here. We're moving from maps in the 20th century to atlases in the 21st century. We have early expedition maps, for example, this one by Gerard van Kulen, 1728. Very early map of Spitsbergen. My own family was involved in exploration too. The Herbert Probert travelled to Congo just about the same time as other explorers came to the Kola-Peninsula. He travelled to the Congo, spent a couple of years there, published a book in 1889, available on the internet. His book, Herbert Probert's on the right-hand side, my great-grandfather on the left, Enoch Probert. So, yeah, another famous explorer was Charles Rabot, French guy. I've got an original copy of the map here that I scanned in the rather ancient scientific publication from France, from Paris, in fact, published in the 1880s. So everything was done without computers, naturally, mapping and overland trips. So more recently, we have the atlas by Makarova that we produced, that was produced by INEP during the 90s. Beautiful publication, many maps produced with a GIS system and then subsequently published. One of the maps there. Another well-known atlas from 1985, the Russian government Arctic Atlas. I've actually got a copy here behind me, one of the 5,000 copies. Another fantastically beautiful atlas, but of course not real-time or interactively intelligent, despite its beauty and historical interest. So now we're moving to the new world of AI and applications in the Arctic. Now, I've been working on neural networks for nearly 50 years. It's linked with machine learning, deep learning. One of the famous companies now, NVIDIA, capitalization exceeding even Microsoft and Apple, so incredibly popular graphical processing chipset. If you don't know about neural networks, I'm not going to give a tutorial now, but they resemble the way neurons work in the human brain, with weights that are tuned up and trained with images or other data sets. AI actually goes back to the early 18th century with Bayesian Learning, introduced by Thomas Bayes here in the UK. Neural networks themselves first defined in 1943, cybernetics 48, and AI itself first coined as an expression in 1956 by John McCarthy. Moving today with transformers, generative AI, ChatGPT, and beyond, exploding in in interest and applications all over the world to every topic imaginable, including the Arctic. So machine learning algorithms using gradient learning, reinforcement learning, neural networks, and so forth. Just a few graphical depictions of how these learning algorithms function in non-real time. Of course, they function far faster on computer sets today. So now I turn to the environment, our Arctic regions and top ecological sectors such as lakes, rivers and oceans. I love atlases. I've collected them for a number of years. Here's a map taken from the Arctic Atlas of Franz Joseph Islands up in the northern Arctic seas. So sectors that will be interested in: water ecosystems, flora and fauna, energy, transportation, human adaptation to the Arctic, industry, and of course meteorology, all requiring remote assets to be networked with real-time communications. Now, looking at our vision for the next 15 years, which are the top 10 areas that I'd recommend applying AI? Well, if you consider all our human footprint around the Arctic, which is roughly 4% of the globe, 20 million kilometers, quite a large area. I've listed what I believe are probably these are my top 10 AI project areas. Starting off with sea ice mapping, where most of the research has been conducted to date. Moving down to permafrost, sea navigation, the industrial impact such as quick response to pollution and oil spills, which takes us back to the original KolaNet project. Climate change, water ecosystems, mesh networks of radio sensors, human settlements with AI being applied to healthcare and adaptation issues, mammals and fauna, tracking animals such as polar bears and Arctic foxes, forests, tundra, flora, and finally, creating a digital twin of the Arctic that we can use and interrogate and converse with in real time as our ultimate aim in 2040. I'm lucky to have visited many of the sites within the Kola-Peninsula, including Colossus mine close to Revda. Back in the 20th century, the main focus was mineral mining, oil and gas, but now we're seeing more and more interest in data. And one of the expressions commonly used is data is the new oil, a key resource. So just imagine Arctic data becoming as valued as much as Arctic oil and minerals during the next 10, 20, 30 years. So let's start to look at the state of our intelligent Arctic today with data sets and satellites. Well, of course, meteorological data is sent to us from across the Arctic. Here we've got satellite mapping of extreme weather. There's been a lot of research starting 5 to 10 years ago in the UK, USA, and of course, Russia and beyond. This is a project for safer navigation in the Arctic environment at Southampton University. And also the British Antarctic Survey undertaking work on AI tackling global environmental challenges. Ice melting quite fast due to climate change in the Arctic. This is just a simulation from the 1980s into about 2012 that will be of high interest to AI applications. So summarizing some of those themes, we're looking at climate change, big data mining of data sets that we already have from ice streams, permafrost, and so forth, classifying data using intelligent analytics, and using deep learning to secure better understanding of controlling and managing climate change during the next 20, 30, 40 years. So I'm thinking of reinventing KolaNet as the foundation for a 21st century intelligent trans-Arctic environmental network. So what may we do for the next 5 years, and what, in fact, research is already underway to tackle some of those issues? Here we've got Novaya Zemlya. Well, current AI projects that I've surveyed include sea ice, forecasting Arctic maritime routes. Extensive work in Spitsbergen, Svalbard, on the Integrated Earth Arctic Observation System. British Antarctic Survey in the UK with their AI research lab. Arcus in United States, surveying all the current Arctic apps data sets. Nordic regions, looking at lichen biomass. Los Alamos in America, satellite images for permafrost mitigation and looking at how that's going to move in the future. US Coast Guard producing new data sets, particularly on sea ice that may be relevant to climate change. Robotic sensor platforms on the ice itself. And finally, again, British Antarctic Survey and the Alan Turing Institute in the UK with their IceNet AI prediction model. But as you see, sort of summarizing those themes, the current focus today and during the next 5 years is sea ice modeling and prediction, because there's clear commercial applications in those areas. This is Arcus, the Arctic Research Consortium of the USA, that is surveying much of this work with a reference there. In Nordic countries, looking at lichen biomass using neural networks, including work within the Kola-Peninsula, Teribaka coast, the system flow diagram of this work, and work just up north from Apatiti, Levozovo, near Revda, of the biomass there and predicted lichen volumes. New data sets are being produced all the time. This is from July last year. The US Coast Guard are developing Coast Guard data sets out on the Arctic ice flows that will be available online through the MIT databases. Robotic sensor platforms, which are being introduced through the British Antarctic Survey and Alan Turing Institute. Their IceNet software application, looking at precisely what we were looking at earlier on the climate change and sea ice melting year on year. Interesting enough, the application is also being used to support animal conservation in the Canadian Arctic Nunavut region up north. I mentioned earlier Los Alamos. They're looking at permafrost modeling using satellite images up in Alaska Territory, the Seaward Peninsula, using machine learning from Earth and space science images. And another program, satellite sea ice mapping using machine learning, trying to fill in the gaps from when it's cloudy and you can't actually see the ice flows, but you can make some predictions using neural networks and machine learning. So let's look now a little further into the future, projects that are already underway and where our vision takes us into the intelligent cyber Arctic. Well, interesting enough, there is already work, new AI projects, particularly focused on the creation of real-time digital or cyber twins using real-time sensors placed across the Arctic, combined with satellite images and measurements from ships that are traveling the region. So work in this direction has been initiated by the British Antarctic Survey, Turing Institute in the UK, as well as recent US-based environmental startup Polar Arctic over in the east coast of the States. So I predict that in the next 15 years, we're going to see a massive growth in artificial intelligence projects supporting the theme of intelligent Arctic environment. Remembering that the Arctic represents just 4% of the Earth's surface, but maybe a template for expanding that, scaling that up to the whole Earth, including maybe Africa, Asia Pacific, South America, and so forth. As I also mentioned earlier, sea ice forecasting, a key theme. These are some of the routes and also drift stations across Russia during the 1930s, 40s. These drift stations moving on ice flows, flowing in the direction of wherever the currents take them, and then transmitting data back to the scientific institutes on land. 25th anniversary of these drift stations, 37 to 1962. And more recently, of course, the 50th anniversary of atomic icebreakers in 2009, many of them working out of the port of Murmansk, just up north from Apatiti. With the melting ice, we're going to see a lot more maritime transportation across the Arctic between 2015 here and then 2040, with even predictions that ships ice reinforced going right across the Arctic. British Antarctic Survey with their AI lab already developing and working on digital twins. Spitsbergen working on their Arctic Earth observation system, and ships across the sea there, and numerous partners including Norsa, University of Oslo and Bergen. Polarctic, this East Coast startup, also working on digital twins, scientific research focus. And just a vision from online of moving from the real world to the cyber world of 2040. So what are your next steps? What are our next steps? Well, I believe, first of all, survey all the current research, launch partnerships between AI institutes and ecological institutes, secure government and business finance, agree a pilot ecological project using AI for the Kola-Peninsula, and 3 further ecological projects with public data sets. Remember to secure your data, otherwise you may have issues with hackers and bad guys stealing this very valuable information. And then 7, launch the first phase of your Arctic projects. And then in 2030, repeat the process and select 5 more sectors as foundations towards an intelligent Arctic and digital twin. So this is what I warned you against. Sometimes you may get hacked. So such surprise attacks, you can prevent them with authentication, encryption, cybersecurity defenses. So make sure you provide that within your project programs. So Vision 2040, moving towards a digital twin, or what I call here a cyber Arctic brain. Just imagine that with generative AI, you'll be able to communicate, converse with the digital twin, almost in human terms, human language, regarding sea ice movements, permafrost, maritime routes, and so forth. Just a vision for the next 15 years. A good colleague of mine who died just 3 years ago, Dr. Alexander Rimsky-Korsakov, he introduced me to the Kola-Peninsula way back in March 92, together with Alexander Beklanov. This is one of his paintings that he made in Karelia, stretching out his research tentacles into one of the beautiful Karelian lakes. I should add that his great-great-grandfather was a composer, as well as the composer's brother, who was a Russian navigator and hydrographer. There was an island in the Pacific named after him back in the mid-19th century, part of the Marshall Islands today. Paintings by Rimsky-Korsakov, very creative, again, all taken from our website. So thank you very much, or everyone. Kola-Peninsula, as it was in 1745, and then moving to an artificial intelligence cyber vision for Kola and the whole Arctic for the next 15 years. You can download all my presentation slides from valentina.net/Arctic.